Hello everyone. In this video, I want to talk about a few advanced topics in Simulink. The first one is the difference between this block here that is called MUX or multiplexer, which it's for combining several signals into one signal basically, right? Like passing 3 wires or 2 wires into a bigger wire, right? As you can see inside your homes. And then there is this block here, which is quite similar in appearance. It's called a bus. So a bus acts basically very similar. You pass several signals into a single combined signal, right? So we want to see what is the difference between these two. And there are their opposites. So demultiplexer, which decomposes that singles basically combined signal into individual ones, or this one here, which is called the bus selector. Not this one, sorry. That is Demux, this one. So the bus selector, which again, you can pick which signals you want from that combined signal in the bus. So that's the first thing we want to do. Then we're going to talk about this guy here, which is the signal converter block. And finally, we want to talk about commenting out blocks like this. So what's the first part? Let's talk about MUX and bus. As I added for you here as comments, as annotations, in a MUX block, data are just arranged based on the order that they are being added, and in a Demux block, they are assessed the same way, which makes it complicated in a very complex system to access. So here, what do we have? Here we have a projectile motion, these blue blocks on the top. This is a projectile motion you see with no air drag or nothing. So AX is 0, AY is negative G. I integrated them twice to get velocity and position. And then this position here is a vector, right? The same as velocity and acceleration, because I combined the accelerations into an acceleration vector A. Now the initial condition for velocity came here from this external output. So in the integrator block, instead of initial condition, say internal and type it in, I say external. And what are these? These are coming from V naught cosine theta and V naught sine theta, where V naught is the launch velocity, theta is the launch angle. So the top ones are with a launch velocity of 40 meters per second and angle of 45 degrees. And you see I combined this V naught cosine and V naught sine into V naught vector and passed it into this integrator, right? So this integrator integrates two entities at the same time, both AX and AY, or the whole A vector. So it gives out the V vector, and then I have the R vector, and here I have the vector of initial positions, 0, 0. And look here, this has two components, X and Y. Now, if I want to access any of them, let's say Y or X, why do I need to access them? Let's say to stop the simulation after the projectile hits the ground. So since I don't know exactly the time of simulation, now in this case, the motion equations of motion are simple. I can have a formula for flight time. But if I don't want to do that and do it based on simulation, I get the y, compare it to 0, and whenever it's less than 0, I stop the simulation, okay? So I need to access the y component out of this position vector, so I have to get a Demux block to decompose it back into the two components. Now, which one is x, which one is y? Right? From these two wires coming out, which one is X, which one is Y? It's based on the order that you put it together. So here, the first element was X, the second element was Y, so the same order is observed here. Now, if this is a very complex system and this wire is not this short and some of the signals are coming from other places in Simulink, this is a very large Simulink, you have to trace it back and see when you first combine those scalars into a vector, which one was first, which one was second, which one was third. Now you might have more than two wires. You have to trace it back to the origin, see the order, and then based on that, when you decompose it back with demultiplexer, then you pick one of them. Okay, so you clearly see as the system gets more and more complicated, tracing these takes time and make it more complicated. Now, is there a better solution? The answer is yes. That's this guy here called the bus creator. So in order to get that, all you need is to say bus creator, okay, and get this block. Now, when you double click on this, It has the number of inputs, just like the MUX does, right? So the MUX also has a number of inputs, but that's it. But the bus has a lot more options. If you click here, not only you have the two, it shows you the name of the signals coming into it, and it has options for what? For filtering. If there are tons of signals in it, you can, and you want to pick one of them or some of them, you can filter those signals, and then you can find them, you can refresh the list, you can move the signals up and down the list. So basically the order, can remove, you can add, and so on and so forth. And I'll show you, okay? So this is very powerful. So here in the bottom, I have another trajectory simulation that you can see. And this trajectory simulation on the bottom, let me get rid of this. It's the exact same thing. This time, the only difference is the angle is 30 degrees and the same velocity, 40 meters per second. Okay, now look here. I'm combining several signals. I'm combining the velocity signals from the top simulation. I'm bringing in the angle of the first simulation, the angle of the second simulation, and the position of the second simulation. Okay, and I combine them into a 6 wire, basically, or 6 entity. You see, I overlaid the dimensions on all by going to debug and then going to information overlay and then clicking on this guy, signal dimensions. So it shows signal dimensions on every wire. And also I overlaid with the legend the sample time on these blocks, because they don't share the same sample time. So the blue blocks on the top, they have a sample time of 0.1, but the red ones have 0.01. Okay, and I deliberately do that. I'll tell you why I did that. And you see, I combined them into this bus. So now it has 6 entities in it, 2 V's, 2 thetas, 2 basically 1 X, 1 Y. And I can send this data to workspace or do whatever I want to them. Okay, so first thing is how to create a bus. And then more important than that, once you create the bus, let's say here, again, I want to stop this simulation or something, I want to do some stopping of the simulation, or I want, let's say, to send something out to an oscilloscope or so. So let's say here, I have 6 signals. I only want this X2 and Y2, Y, or maybe just Y2. I want to just send this Y2 out with the Y1 from the top simulation. So in the scope block, I want to show the heights of the first projectile and the second projectile, both on the same scope versus time. So look here. If I double click on this, you should be able to see both of these Y's versus time. There we go. You see? So here the first projectile stopped, the second projectile with 45-degree angle still up in the air when we stop the simulation. Okay. Now note that this stop block can only act, one of them will act, right? So once the one with smaller angle hits the ground, that will stop. So the second one will never really act. Okay, now going back to what I was saying. So now I have 6 wires. Which one was this X2, Y2? Okay. If I want to know which one was this X2, Y2, so I can pick the Y2 out of it, how do I pick it? So I have to, you might say, well, go back and see, hey, this signal that you wanted was the last one, so pick the last one. But with the bus selector, I have a much better solution than just tracing it back. Look here, if I go back, it shows me which entities, which physical quantities are available in the signal with the name, and then I can right click on them and simply add them to the output. So I get to pick exactly instead of just tracing. And that is way more powerful for organizing stuff. Okay? So you see the power of bus. Now first, let's talk about creating a bus. So one way is, of course, to bring the bus block, like I showed you, change the number of inputs, and then wire the signal into it. But there is another way that you can create a bus. Let me show you that way. So here, let's say I have 2 signals. Okay, let's go down here. Let's move this guy up a little bit. So let's say, for instance, I want to bring the R2 and V, or V2 in this case, really. I want to bring these 4 signals and then combine them into a bus, right? So here, I get a wire from R2 like this, and I get a wire from V2 like that, okay? And I can add as many as I want. So now what? Now I can create a bus from these 2 without even bringing the bus block. I just pick these 2. It gives me these 3 dots, and once you click on that 3 dot, look again, click on that, it's simple, just hover the mouse over that. It allows you to put it in Observer, to basically log it so you can look at it in Data Inspector. And look here, it allows you to auto route the lines which you don't want. This last one is a bus creator. So you just click there, boom, the bus is there. Now, it's always important in Simulink to name the wire. So if you already named the wire, now when I double click on this, you see the name populates on this wire and here. Now, if you look inside this, those 2 names will appear inside the bus. Look. R2 is X2, Y2, V2 is V2X and V2Y. You see? So now the wires have N names and tags in the bus as opposed to just an order. Now, I can add some other thing to this, or I can reorder it. Let's say, for instance, I want to bring V2 to the top, R2 to the bottom. Can I do that? Yes. I click on V2 and then say, move it up. Now, look what happens when I apply that. Did you see? V2 now went to the top entry, R2 became the bottom entry. You see? So you can easily rearrange the, basically, the order here. Right, just like that, up or down. Okay, yes? Now, let's say I want to add something. So I click on the add. It says new signal, right? Now, if I apply that, you see, it adds a new entry for me in the second position. Now, let's say I want it to go down. So I click, bring it down. So that's my third one. Now, what is this new signal one, right? This is a new signal. But now you can wire it to whatever you want. So let's say, for instance, I wire it to A, correct? So I wire it back to A. So I bring also A. So that's how you simply add another signal. And if you don't like it, you can simply go back and remove it. So here you click on this and remove it. Boom. Okay. So you can easily do that. And if you have a ton of signals here, you can search them inside this list. Okay. So you can find them. You can refresh your list or anything you want. So you see, you have a lot more organization power here compared to the MUX and Demux. Now, let's talk about the bus selector, which is the same as the MUX. Now here, look, I have 4 sets of signals to it. Which one do I want to send out? I'm not gonna, I don't have to basically make sure that the number of outputs of this are the same as the number of inputs of the original MUX. So if here I put 2 signals together, here I send out 2 signals out. So the first one corresponds to the first one, the second one corresponds to the second one. I don't have to. I have 6 signals, 6 numbers here, or 4 wires. 2 of them are vectors. If I want to send only the one that is called X2, Y2, all I need to do is, look here, let me remove this. All I need is, I have the names of the signals. I go here and then simply what? Click on this, out to the output. Done. You see? Okay. Or if I don't want it, I can add another one or another one. So here, let's say, for instance, you see that one was just R2. Now, if I want, let's say also send V1 out. So let me send this out and okay that. You see, now you have the second output added. That is automatically, as soon as you bring the wire out, it says, hey, this guy is V1. You see the power of it, right? Much more convenient for organization and basically doing the job properly. So this is bus creator and bus selector. Now, you might read here and there that the MUX cannot combine signals of different dimensions. Yes, it can. Actually, if you look here, I combine a signal that is continuous with one and it has dimension of 2 by 1 or 1 by 2 and a scalar and another scalar. So I can combine the scalars and vectors together, okay? The same thing that I can do with a bus. So merging signals with different dimensions is no worries in a MUX or in a bus. They both can do it. How about different sample times? Can I combine different sample times in a MUX? Yes, I can. Look here, this one is 0.1, this one is 0.01, and bus can do that too. So both of them have the power to do it, but now let's talk about something interesting. That is another component that we have in buses is called a non-virtual bus. The bus that we have created here, this guy is a virtual bus. There is another thing called a non-virtual bus. What is that? Let's talk about that. So a virtual bus, which is what you have seen so far, is basically what? A logical grouping of signals that only exist for visual organization and ease of modeling, just like what we explained. We regroup them with names, and it's really easy to put them in a group and simulate and get the signals out and so on. Now, a non-virtual bus is a real data structure. Basically, you treat it as a single entity during simulation and when you generate code for embedded systems. If you want to now create a code from this and download it on a robot or something in embedded systems, when it generates the C code from your Simulink, it treats that the non-virtual bus as a new data, as a new variable, as a single entity. Okay? So it needs a little bit more memory to keep in mind what was what, and the structure of it is more rigid. Okay? What do you mean by more rigid? What do you mean by memory? Let's explain that. In a virtual bus, data can have different dimensions and sample times, as I showed you, but not in a non-virtual bus. In a non-virtual bus, if you want to merge data together, you cannot combine vectors and scalars. You cannot combine data with sample time of 0.1 and 0.01. So this data that we generated here in this virtual bus is good for visualization and everything. But if I get to convert it into a non-virtual for code generation, can I do that? The answer is, guess what? You cannot do that. You're going to get an error. Really? First of all, how would you convert a virtual to a non-virtual? To do that, we need this block called the signal conversion. Okay, so you just double click anywhere and type in signal conversion. It brings this for you. Now, if you double click on this, you see the output could be simply a copy of the input or could be a virtual or a non-virtual bus. So if I have a virtual one and I want to convert it to a non-virtual, I just pick this last option and I OK that. Right? Like this. And then you get this one. So now the signal coming here, this is a non-virtual one, which is good for converting into C code and deploying to a physical system. Okay. Now, would I get error here? Because this one was basically it was made of signals with different dimensions and different sample times. Would I get an error? Absolutely, you will. Let me show you how. So here I commented out these two blocks so they are not effective, so you don't get error. You see, when I run, you don't get any error. Why? Because this one is commented out. But if I uncommented, would I get an error? Yes, I will. Look here. So I pick these two, right? And let's see here, uncomment. So now I'm ready to run it. Look what happens. There we go. Boom. You got the error. Okay. You see? So now you got your error. It's not going to work. So make sure you combine similar signals with similar dimensions and similar data types into a bus if you want to convert it to a non-virtual bus. Now, how did I comment a block? All I need is to simply highlight the block or all of the blocks or wires or anything. Go to these three dots and then what? Comment the block out. Then that portion goes gray and it will not be effective. So to summarize, I showed you what is the difference between a bus creator and a mux, and also a bus selector and a demux. We learned that there is something called non-virtual bus, which is different from a virtual bus. It's good for basically code generation and embedded systems. It needs, let me add this extra thing for you here, that a virtual bus does not require additional memory or computational resources, but a non-virtual one, it needs to hold the structured data. Okay, so a non-virtual bus basically slows down your code a little bit, and also basically requires some extra memory, because you literally created a structure, a new entity, a new type of data. So you need some extra resources to use that. And also we learned that to convert virtual to non-virtual or vice versa, we have to use this signal conversion block, and then you can comment or uncomment the blocks. By the way, I mentioned it in one of my previous videos, but if you want to put these legends or colors on signals based on their sample time, you can always click on this guy, sample time. Okay, and you can see that sample time here, right? And this shows here. Let me close it and show you one more time. So you go here, if you just say colors, and you see the legend shows up showing each data is of what sample time. So hopefully this video was useful to you, and I'll see you in the next lecture. Thank you.